Every year, millions of people in the world die from cancer. In 2021 alone, nearly 10 million lives were lost globally. Meanwhile, in the United States alone, we spend over $200 billion to fight cancer. Despite that, traditional treatment methods like chemotherapy and radiation therapy often damage healthy tissues along with cancerous cells. So the question is, can we treat cancer more precisely and safely? One promising solution is GORD nanoparticle-assisted drug delivery. We can attach drug molecules like gene, protein, or antibiotics to these tiny nanoparticles and deliver them exactly to the tumor. And when exposed to laser, they heat up, they triggers a chemical reaction and delivers that nanoparticle exactly to where it's needed. This method, known as photothermal therapy, has been successfully implemented on mice with promising results, such as 90% success rate in some cases. But there's a catch. If the temperature is not controlled properly, it can damage healthy cells, melting of the nanoparticle, and even cause systematic side effects like nausea, fever, inflammation, etc. The main problem, current methods focuses too much on generating heat, but not enough on how to remove this heat from the nanoparticle. And that's where my research comes in. Instead of focusing on the laser, we study how heat moves from the nanoparticle into the surrounding medium that we call interfacial heat transfer. Using atomistic simulation methods, we study how parameters like nanoparticle shape and size, surface ligand type, interfacial chemistry, and liquid structuring around the nanoparticle influence this heat flow. By understanding and controlling these parameters, we aim to design a safer and smarter nanoparticle therapy. Thank you very much.